Hi there. Welcome to TechSpace with Neha. Today, we're going to see how to create a Q&A chatbot with your personal data using Langchain and ChatGPT. What is Langchain? Langchain is an open source developer framework that is used to create LLM-based applications. So first we'll go over the steps, how to create the Q&A chatbot. Then we'll see how Langchain fits at each step. And finally, we'll have a quick glance at the code. Let's get started. So the first step in the process is to load your document. Many variety of documents can be loaded, like URLs, PDFs, databases, YouTube data, Twitter data, and so on. Once these documents are loaded, then they're converted into a standardized format called a document object. The second step in the process is the splitting part, wherein this document object is split into multiple chunks for easy handling. Then the third step consists of two steps, basically. The first one will be to convert these chunks into embeddings, which are nothing but numerical representations based upon the content of the text. Similar content text will have similar kind of vector representations. And then storing these vector representations or embeddings in the database, which is known as the vector store. So this completes the storage part. Then starts the retrieval part, wherein once the query is received, the vector store is searched for relevant results based upon the context, which is the query, and relevant splits of those chunks are gathered. And then these relevant splits of the data are then passed on to the LLM, like the ChatGPT, along with the prompt setting the context to get the final answer. So let's now see how the flow goes from your question to the answer. When you ask the question, it is sent to the conversational retrieval chain of the Langchain along with the chat history. Think of this like a chain which binds your question to your chat history for the current session and then converts it into a standalone question to be asked to the vector store or the retriever. From this standalone question, whatever answers that you receive based upon the search of the vector store, these relevant splits are then passed as a system prompt or a context to the ChatGPT or any other LLM along with your human question. Then the ChatGPT or any other LLM takes the system prompt or context and your current human question and then sends you the answer. Let's move on. Now let's see how Langchain helps at each step. So we saw all the steps. Let's see which module of Langchain helps at each step of the process. The first part that we saw was the document loading. So the document loaders from Langchain help in document loading. They can help to access and convert the data from a variety of different sources or formats to a standardized format, which is the document object. Incoming data can vary from structured to unstructured, from public data to proprietary data. Langchain supports 80 plus document loaders. And examples include websites, databases, YouTube, Twitter, PDF, HTML, JSON, Word, and so on. The next part was the splitting, wherein the splitters from the Langchain help. What do splitters do? They create chunks from the loaded documents based on the provided separator and chunk size. Separator can be a new line separator, character separator, space separator, and so on. Langchain supports 10 plus text splitter implementations. And some examples include character text splitter. Based on the tokens, we can split the text, which is a token text splitter. Markdown header text splitter, which is a splitting based upon the headings, and so on. Next step in the process is the embeddings, wherein the vector representations or the numeric representations of the text based upon the content of the data is created. Langchain supports 10 plus text embedding integrations, and one such integration is OpenAI embeddings. Text with similar content will have similar vectors so that we can compare the vectors and find pieces of text that are similar. This is called semantic search. The next step is a storage step, wherein these embeddings will be stored into a database which is called vector store. So these are the databases that are used to store and retrieve similar vectors, which is semantic search and retrieval. Langchain supports 30 plus vector stores. Few examples are Chroma, which is in memory, Pinecone, Quadrant, etc. The next step is the retrieval part, wherein multiple search options can be provided on the vector database. Langchain provides multiple search options on vector database in order to retrieve most relevant chunks based upon the query. Some of them are similarity search, which will retrieve k most similar chunks, where you have provided the k as an argument. Maximum marginal relevance search, which will retrieve the k most similar chunks, and from them it will retrieve n most diverse chunks from the data. Then we have the self-query retriever to filter on metadata in the vector store and then apply the query. And finally, we have the contextual compression retriever using LLM to get only the relevant data from the chunk retrieved. Otherwise, it will pass on the whole chunk. And if you just want to shorten the length of the relevant data which has been retrieved, you use this particular retriever. The next part is the question answering part. So how does Langchain help here? It integrates chat models and provides chains. So chat models like ChatOpenAI, they are used to answer the question. Now it also provides, Langchain provides the chains like retrieval chain, conversational retrieval chain, and so on, which helps in to enable question answering backed by a retrieval step, wherein your vector DB will be searched and retrieve some part of the contextual data, and then this data will be then passed on to the LLM to answer the question. Langchain also provides prompt template to pass the context and the question to the chain, which binds them together, and this enables LLM to consider the contextual information returned from the vector store while answering the question. And the last step is the conversational bot with memory, wherein you have the conversational retrieval chain. So unless you have the memory or the context of the chat history, it will be just a new session every time you ask a question, an answer pops up. But when you ask a follow-up question, the past history of the session will not be considered. Now, for this solution, we have a conversational retrieval chain, which will bind together the current question with the chat history from the current session, and then it will pass it on to the vector store as a single question to get the retrieved results based upon the context provided. So chat history is added as an additional context to answer the question, to get the answers for follow-up questions. And for this, we have to use a memory. For Langchain supports different kinds of memories. One such is conversational buffer memory that keeps buffer of the chat message in history, and then it passes those along with a question to the chatbot every time. Langchain supports many memory types, and it's possible to have an external memory as well. Conversational retrieval chain takes in history question, creates a standalone question, and passes it on to the vector store to look up the relevant documents. This we have discussed already. So now let's have a quick glance at the code. So what we have discussed, it is just now shown as part of the code here. The first step is to load the API key for the OpenAI if you're using the ChatGPT model. The second step is to load the documents. For example, for the PDF file, we'll use the PyPDF loader and we will load the document. And then the second step is to convert this document into splits, wherein we define a splitter. So here we have defined a character text splitter with a separator of new line with a chunk size of 1000. And then we apply this text splitter onto the document which was loaded, and we get a new variable here. Then the next step is to create the embeddings. As discussed, Langchain supports the multiple integrations for embeddings model, and here we have used OpenAI embeddings to create the embeddings, which are the numerical representations of the text based upon the content of the data. The next step is the vector DB, wherein you store these embeddings into a vector store. So this will be actually retrieved when the retrieval step comes. After that, so storage part is done in the vector DB. Now what we have to do is we have to assign conversational buffer memory so that we have a memory where the chat history is saved for the current session. So after that step is also done, then we create an LLM instance, which is nothing but we pass on the model name which we are using here. We are using model name for GPT 3.5 Turbo, which is a ChatGPT model with a temperature of 0, which means there is no randomness in the results. It is more like, factual results are returned. And then finally, we combine all this. What we do is we pass on to this chat OpenAI, we pass on the retriever as the vector DB, then we pass on the memory, and finally when the question is asked, it is asked to this chain which we just created, the conversational retrieval chain. The question goes in there, and so the question is passed along with the memory, the chat history, and then it is passed on to the retriever wherein the results are retrieved, and then this enables the LLM to answer that question. Hope this session was helpful, and if we want to see the tutorial, please give a shout out in the comments. I would love to do that. Thank you so much for watching. Have a nice day.